Investigate the series at n go from 2 to infinity of 1 over the cube root of n squared plus 3. Observe that this series looks like, when we use the term looks like, we only look at the leading terms. It looks like the series 1 over n squared to the 1/3, which is 1 over n to third power. This is a p series with p equal 2 over 3, which is less than 1. So we know that the series diverges. But this is only the conjecture. This is not the justification. This is not the work. If we want to conclude that the given series is convergent or divergent, we have to use certain tests, and we cannot use the p-series test because this is not a p-series. And if we are going to compare it with another series, then we need to come up with a good inequality. In this case, observe that n squared plus 3 is greater than or equal to n squared at n go from 2 to infinity. Then we raise both sides to 1/3 power. The inequality still holds because the left and the right hand side are both positive. Then we take the reciprocal. 1 over n squared plus 3 to the 1/3 power is now less than 1 over n to the 2/3. We see that the series 1 over n 2/3 is divergent because this is the p series with p equal to 2/3, which is less than 1. But this is a useless inequality because for a series to be divergent as well, we would need these terms have to be greater than the term of the divergent series. The inequality that we came up with does not work, so we need to try another inequalities. Perhaps we compare this with the series 1 over n. Remember that the series 1 over n is a harmonic divergent series. In order to state that this given series is also divergent, because we suspect that it is divergent, we need the terms of the given series to be greater than 1 over n. What this means is that we need to show that 1 over n is less than 1 over n squared plus 3 to the 1/3 power. If we can show these inequalities, then we can conclude that the given series is greater than the harmonic series. Then, by the comparison test, it is also divergent. But how do we show these inequalities? First, observe that we can multiply n squared plus 3 to the 1/3 power to both sides of the inequality, and the inequality still holds. We then multiply n to both sides of the inequalities, and again, the inequality still holds because all of these are positive. Therefore, we have n squared plus 3 to the 1/3 power less than n, which is equivalent to the inequality that we want to show. This means to show that 1 over n is less than 1 over the cube root of n squared plus 3, it suffices to show that the cube root of n squared plus 3 is less than n. But this is also equivalent to showing n squared plus 3 less than n cubed. But this is also equivalent to n cubed minus n squared minus 3 greater than 0. And to show this, we first let f of x equals x cubed minus x squared minus 3. The derivative of this function is 3x squared minus 2x. And we see that this can be factored to 3 times x, and then multiply x minus 2 over 3. This is positive if x is greater than 2/3 or x is greater than or equal to 2, because the starting index is 2. X is n in this case, so the first factor is always positive. What we just shows here is that the derivative is positive. If the derivative is positive, then the function is increasing. But observe that f of 2 equal 2 cubed minus 2 squared minus 3, which is 8 minus 4 minus 3, or 1. We start with n equals 2, where a sub 2 equals 1. And we know that the derivative is positive, so the terms will be increasing. What this means is that the a sub n terms will always be greater than or equal to 1. But remember that a sub n in the continuous function is f of x. What we just showed here is that f of x will always be positive, or n cubed minus n squared minus 3 is positive, which means n squared plus 3 is less than n cubed, which means the cube root of n squared plus 3 is less than n, and therefore 1 over n is less than 1 over n squared plus 3 raised to the 1/3 power. Now, since we show that 1 over n is less than 1 over n squared plus 3 to the 1/3 power, and we know that the series 1 over n is divergent. Therefore, the larger series 1 over n squared plus 3 to the 1/3 is also divergent by the direct comparison test. We should always state the name of the test we use. In this case, it is the direct comparison test.